We did lesson 10 today, which was connecting equations to graphs. Really important skills. I mean, the curriculum has you doing activities in order to learn. But the really important parts are when I go over in between, critiquing these answers, saying what's right and wrong about them. I feel like that was lost on a lot of people. But regardless, this is what you're going to be assessed on, the learning targets. You need to be able to describe connections between an equation in this format, the features of its graph, and the rate of change in the situation. So what are some key features of a graph that we discussed today? The y-intercept, so when it touches on your y-axis. Can I see the y-intercept super clearly in equations that look something like this? So like, for example, x plus 4y equals 28. Can I see the y-intercept super clearly? What's the y-intercept? So the y-intercept for this, and this was one of the examples, was 7. So can you see it really clearly from this form, the y-intercept? No. You might recognize it as the c divided by whatever b is. I personally don't like memorizing random stuff like that, but that's what we're talking about, is that there's pros and cons to each format. Pay attention, I'm not doing this for me. I already know all of that. I got lots of other work to do. So there's pros and cons to each form. In this form, can I clearly see the y-intercept? For example, if my y-intercept is 7, can I clearly see it from here? No. So that's where you might prefer the other forms of our linear equations, which one of them we reviewed today. What is another way to write this? The formula for a straight line. Y equals mx plus b. And that seems to be what most of you are used to. Can I see my y-intercept really clearly when it's in y equals mx plus b form? Yeah, you can, because it's in the name, slope-intercept form. I can see my y-intercept really clearly. It's whatever the constant is in the equation is my y-intercept. It's y equals mx plus b. Can't really see it go in this one. What are some other features of the graph we talked about today? I need you looking at the screen. I'm talking to all of you. The slope. Can I see the slope really clearly when it's in standard form? That ax plus by equals c. Was I able to see the slope really clearly? All right, not necessarily. In some of ours, it was kind of easy because the other one had a coefficient of 1. So like dividing by 1 doesn't really change things. But it is easier to see the slope in slope-intercept form. It's always the number that's in front of the x. And that is a feature of the graph. It tells me my rate of change. So how steep my graph is. So rate of change is another way to say slope. So if you can make it into slope-intercept form, you can say what the rate of change is. It just might be worded slightly differently. So like if your slope is -1, you would say that it's decreasing by 1 each time, but you wouldn't say it's decreasing by -1. It's just like some wording. You need to be able to interpret what's going on in the real situation. The last thing was rewriting from standard form to slope-intercept form, which we covered the past 2 days as well. What is alone in slope-intercept form? On one side of the equal sign, what's alone? The y, not the y-intercept. The y-intercept is b. The y is alone. That's like your output. You have inputs and outputs. But the y is what's alone. So if I have something in standard form and I want to see things like the slope and the y-intercept super clearly, I just need to rewrite it into slope intercept form by isolating the y. So let's do that. If I'm trying to isolate the y, what do I need to get rid of first? And what is farthest from the y? The ax. Together, because the way you make it disappear is by making it 0 plus by. Then you don't have to write what's to the left of it. How do I cancel the ax? And subtraction, not division. Division would make it 1. You want to make it 0. Whatever you do on one side. Yep, they're not like terms, so you can't combine them. I have by equals, and you could reverse the order, it doesn't really matter. Negative ax plus c, so c is still positive, a is still negative. And what is opposite of multiplying by b? And typically a and c are numbers. Typically you have to simplify the numbers, simplify the fractions at least. But that is essentially how you isolate things. It's your food steps. It's just that you're rewriting, and you won't get that y is this number. You'll get that y is this expression. All right, so lots of really important skills in this one. I'll leave it on this screen while you do your practice. If you have questions, you can let me know. So the lesson we did today was lesson 10. Everything prior to this lesson should already be done. So if it's not, make sure we're not just like, I don't know, getting the bare minimum and then moving off. Make sure all your missing work is done. Make sure that if you have a low grade in math lab, it's probably because you have something that was turned in and it was a low grade that you need to resubmit, or you just never turn it in at all. I do have some that still need to be regraded, but like, you guys need to be accountable for yourself. In 10 practice number 5. So to raise funds for uniforms and travel expenses, the soccer team is holding a car wash in a part of town with a lot of car and truck traffic. The team spent $90 on supplies like sponges and soap. They plan to charge $10 per car, $20 per truck. Their goal is to raise $460. How many cars do they need to have wash if they wash the following number of trucks? So you could problem solve your way through it, but I think it'd be easier to make the equation and then plug in and solve, because we have all these different ones to answer. So kind of like the format we did today is probably going to be the same format for all the word problems. So when you have a word problem, you look for what first? The number that should be by itself, which is like a total of some sort. 460 is the total money that they want to raise, right? And you have to think of everything that contributes or even takes away from that money, and that goes on the other side. So then like all these other number values are probably going to be in the equation, and you just have to figure out what math needs to be done for them. So like the $90 on supplies that they have to spend, does that take away or add to the total?
Take away.
So in this, it's gonna be something minus 90 probably, or negative 90 plus everything else. Then they plan to charge 10 per car and 20 per truck. How can I write that with like numbers, variables, symbols? And anything else? So 10 in front of the C, because it's 10 per car, that would be like for however many cars, or 19 by 10. And then 20 per truck. So this would be the equation. And you can simplify, like you probably actually make it really easy for you. But this is our setup for answering these. So like if I have 4 trucks, hold on. And I want to figure out how many cars. Well, what I'm figuring out is the unknown, so it's going to stay a variable. The 4 trucks needs to go in the T spot. And then I need to solve. So what is 20 times 4? 80, what's 80 minus 90? -10. And we're solving for C. So get rid of what's farther. How do I get rid of this -10? Whatever you do on one side. And then I get 10C equals 460 plus 10 is 470. Opposite of multiplying 10 is, and so the number of cars they need to do is 47. Does that help? Do you think you can figure out the rest, or do you need to see like another one? Let's see if there's another variations. Okay, so these are all trucks. So all you're changing each time is the value of T. And if you do what we did the other day with like the rearranging and stuff, you can make it even easier if you have the C isolated from the beginning. You can. Or you can just plug in each time and solve each time, whatever gets you the right answer. But if I wanted to have something that makes it easier to solve for C, I might rearrange this to begin with. So like I would add 90 to both sides. What's 460 plus 90? $550, and that's positive, so I'll put plus 550. And then if I want to move this 20T to the other side, I'd have to subtract it from both sides. This might even make it a little easier to solve the rest. If you just plug in for T and do this, you should get how many would be even easier. And that's when we need to put in the calculator. So I'll let you try that. If we need to come back to it, because you're still getting it marked wrong, I can go back to it. But what other questions do we have, if any? Amy? 3 on the lesson 10 practice? So, a group of hikers is progressing steadily along an uphill trail. The graph shows their elevation or height above sea level in feet at each distance from the start of the trail in miles. What's the slope of the graph? What does the slope tell us? And which equation represents it? So lots of parts. And does this equation represent the same relationship? Okay. So to tell slope from a graph, because I don't have an equation anywhere, I don't think. Okay, I don't. That's where you do the rise over run. So to do that effectively, you need to find 2 areas that you can see really well on the graph. And here's like what I mean about that. So like areas that you wouldn't have to estimate. So like here would be a good one. Here would also be a good one. Do you see? Now this is actually pretty important. Can you guys all pay attention to this real quick? When I say like points that are easy to see, like values that you don't have to estimate. So like this first coordinate is 0, 500. The second is 2, 1000. Whereas if I picked like, I don't know, here, now I'm having to estimate what's in between 500 and 1000, and I could be wrong. So pick points that are easy to see. And any 2 points that are easy to see, make a triangle. And count your rise and your run. Now also pay attention to how these are numbered. So if I'm going from this point to that point, how much am I going up? But like 1500 to 2000. I'm going up 500. And to the right, from this point to that point, I'm going to the right, how many? 2, because that's 4 to 6, right? So the increments do matter. And what's 500 divided by 2? 250. So my slope is 250 for this one. Questions on that so far? Okay, 250. What does the slope tell us about the situation? So slope is always like your rate of change. So whatever situation is going on, your slope is what it's changing by each time. And it's like, since it's rise over run, you could say like change in y over change in x as well. Read your axes. My y-axis is elevation. So it's going up 250 feet for every, and then that's where you read your x-axis, every mile along the trail. Questions on that? Slope is rise over run. So read your axes, y over x. If my slope is 250, you can imagine that it's over 1 because all numbers are over 1. It's changing 250 feet for every 1 mile along the trail. Let's see what our option is. It tells us how many feet the hiker's elevation increases or decreases. Increases because it goes up from left to right, like how you read, and it's positive. Which equation represents the relationship between the hiker's distance from the start of the trail, x, and their elevation, y? Both of these are in what format? Good. Granted, it's in a slightly different order, the way they have it written. But you guys should know slope is always in front of what? The x. And we just found our slope to be 250. So it's going to be this one. And they wrote it just kind of in a different order. They're allowed to do that so long as they don't change the signs or anything. Like the 250 is still my slope in front of the x. Good. Okay. Now, what does this equation, y minus 250x equals 500 represent, or does it represent the same relationship? If I can rearrange the top one to get this one, then it would, because they're equivalent equations. They would represent the situation. So, see the difference between this one and that one, what changed? Okay, they moved the 250x to the other side, because it's no longer on this side. How would I do that? What math would I do? And did they do it on both sides? Yeah, they did. Because y and the x are not like terms, you can't like combine them, you just rewrite it. Make sense? These are really good homework questions. Not to like nerd out, but like they really like hit all the parts you need to know. So yes, it does represent the same relationship because you can manipulate this one to get that one. You can. Let me make sure the key is right. I'm confident in all my answers, but sometimes the key is wrong. So let me check. I'll scroll. Okay, yeah, the key is right. Other questions at all? It could be any practice, any worksheet. We getting our stuff done. We have good grades. Austin? Did you say lesson 11? Okay. So some preview of what we're doing tomorrow. Okay. So what is the slope? First, let me ask you, is this in slope-intercept form? What's the formula for slope-intercept form? And when it's in this form, it's really easy to see your slope because then it's just what's in front of the x. So what I'm going to do is I'm going to rearrange this into this form by getting the y by itself. So if I want to isolate the y, what do I need to get rid of first? How do I get rid of it? whatever you do on one side. So then that cancels, I get negative 2y equals, these are not like terms, don't try to combine them. What I will do is write them in this order, so it looks more like this. But that's just my preference, not changing anything. What's opposite of multiplying negative 2? And whatever you do on one side. And because there's numbers, you can usually simplify, so that's why I'm writing it like this. You remember to simplify. And what happens when I have a negative divided by a negative? So my slope ends up being this, and it is allowed to be a fraction. That's totally fine as long as it's a simplified fraction. And my y-intercept is negative 10 because it's simplified, but it just asks about the slope. Yes.
You're dividing 20 by 2.
Yeah. So the positive, like the plus 20, changed to minus 10. So normally we won't write plus negative 10 because it's kind of like redundant. We'll just like put minus 10. It's the same thing though. All right, other questions? Good question. Okay, yes? Oh. Number 4 on lesson 10. Okay, so a kindergarten teacher bought $21 worth of stickers and cardstock for his class. The stickers cost this much, cardstock costs that much. This equation represents the relationship between S packs of cardstocks and I think I said that wrong. Stickers S, cardstock C, and the dollar amount a kindergarten teacher spent on those supplies. Complete the following to explain how can we tell that this graph represents the situation. So if we substitute the pairs of coordinate values of the points on the graph into the equation, and let me write down that equation so I don't have to keep scrolling. All right, but they're saying if I plug these in, so this would be like because of the x-axis, the first number in each parentheses is for stickers. The second is for cardstock. They're saying if I plug those in, we will or will not have true statements, like true or false statements that mean that they are solutions to the equation. If they are solutions, then those statements would have to be true or false. So I can still check to see that they are true, but it said, which means those points are solutions. So they have to be true statements if they are solutions. So without even doing the math, I'm going to say that because it's not saying they're wrong. They're just saying to prove that they're solutions. Then it says complete the following to explain what the vertical and horizontal intercepts mean in this situation. So remember, it goes S and then C. So the vertical intercept of 0, 6 means that if the teacher bought no stickers, he must have 6 packs of cardstock. The horizontal one says that if he bought no cardstock, because that's the 0, then he must have bought this many stickers, 14 stickers. Good, makes sense? Okay. Well, thanks, guys. Thanks for asking lots of questions.